Hey everybody, welcome to the AWS Containers Workshop. We're going to get started in just a minute. We're going to give just a couple of minutes for people to roll in. All right, everybody. Welcome to the AWS Containers Workshop featuring ClearScale. I am Jay Martin, essentially your host and air traffic control for the next few hours. As you likely already know, this interactive lab will provide a working understanding of containers and the various products you are likely to utilize, including Docker, ECS, Fargate, and much more. This is absolutely interactive, so please utilize the chat on the right side of your screen if you need assistance or have questions for our presenters. You should have received an email reminder about 15 minutes ago for the workshop. This email not only provided a link to today's workshop, but it also included some very important bits of information related to our labs and logging in. Certainly, if for any reason you didn't receive the email, certainly spam blockers and other things pop up, security, we can provide all the information at the appropriate time when we get to the labs. All right, here we go. We have brought in a massive and wonderful team of experts standing by to assist at all times, so please don't hesitate to reach out. Our main speakers for the day and trainers include Stephen David, an enterprise solutions architect from Amazon Web Services, Greg Fina, a senior solutions architect also from AWS, Christian Tomaldon, another excellent AWS solutions architect, and finally, ClearScale's very own Jimmy Chu, our director of customer success. Outside of our main presenters, we do have a collection of support staff ready to answer your questions, both during the presentation and during the labs. No question is going to be too big or too small. If needed, they can also directly message you in the system to provide a more private and exclusive conversation if needed. Before we get started, Jimmy, if you would please give a brief introduction to yourself as well as ClearScale.
Sure. Hi, everybody. Jimmy Chu here. I'm the Director of Customer Success at ClearScale, and I've been helping our customers build, modernize, and really grow their business in AWS and as an organization for the last almost 7 years. In ClearScale, we started out probably 11 years ago, got really excited about AWS and just went, both feet in. We've been an AWS only partner this entire time. We started off with doing migrations and DevOps automation, and just continued to grow our business from there. We had a lot of experience also with building products, so application development, and then over the years we've just grown bigger and have had so much experience helping people modernize their technology, right? And not just technology, but guide them on this journey of how do we advance our people, our processes, and really take hold of what does modernization, what does rapid application delivery mean, right? How do we get to that pinnacle of innovation? And that's what we've been doing all these years. We believe heavily in AWS certifications as well, and training. And so, our engineers are well certified, and then we've gone out and achieved all of these competencies. And it's a huge list there. And all of this is driven to support our customers. And then I'm gonna hand it over to Stephen to talk a little bit about AWS.
Hi, everybody. So my name is Stephen David. I'm a principal solutions architect here at AWS. And AWS has got a wide range of services. We cover most things that you can do in IT services nowadays. Today, we're going to focus on ECS as our technology of choice. Even in the container ecosystem, there's actually quite a number of ways you can do orchestration or just running of containers in AWS. And that's exciting. And each of them have their purpose for living in that ecosystem. And today we're focusing on our Elastic Container Service. We'll dive deeper into that. That service does back a number of other services in AWS, if you're familiar with Batch or Lex, SageMaker. Many of those will use ECS behind the scenes to help them get their jobs done. It's a very powerful service. It can scale up. It can meet your enterprise needs for container orchestration and management. And I look forward to diving into that.
All right. Thank you, guys. Well, today we have a three-pronged approach to our workshop where we're going to start with an introduction to containers, starting with Jimmy and Stephen. Then we're going to take a short break and we'll explore the utilization of ECS and Fargate with Greg Fina and Christian Tamaldan. And finally, we're going to open the floor for questions. Again, please flood our chat with all of your questions completely related to containers or maybe not. And we're happy to just have that conversation with you and answer everything that we can. But without further delay, I'm going to pass it over to Jimmy to provide our introduction to containers and Docker. Jimmy, the floor is yours.
All right, perfect. Hey guys, so introduction to containers and Dockers. Like what is a container and why are customers using them? And I like the image of a container. It's really this container construct that we have a box and then we can isolate a process. You can think of it as an application or I like to relate this to my own life, and I like to be active and outdoors. So I imagine this being my box that like I'm gonna go kayaking, right? And all of my kayak gear fits in this box, right? So everything that I need to do that is in there. And then I also think about, just add water. So, I can take that container of my kayaking gear anywhere there's water and it's gonna work the same. So we'll kind of explore what that means, from a technology perspective, right? So when we talk about having a container, what we're talking about is being able to package up your runtime engine, right? And any other dependencies that app is running. So we may have, this is going to be a JVM. We've got some, some libraries in there. The actual code that we want to, package up in this container, as well as configurations. And when we can take all of this together and call this a deployable, let's say this is a deployable unit that can run on its own, right? Same thing as my kayaking gear, right? That's my helmet, my kayak, that silly rubber booty that's around your waist that attaches you there, and so on, paddles, etc. So now that we have that construct, I mean, that's what makes up the application, but we want to jump back to, before containers. And I don't know if you guys can relate. I've been in many of conversations where we've had, individuals from the organization have the discussion of, well, it's the app that's not working in staging or production. Oh no, it's the infrastructure that's not working in staging or production. It's this configuration. It's this. It's that. And that's common when you have different hardware platforms and different drivers, or maybe the operating systems don't match up perfectly. The patching levels don't work right. And more often than not, that is the discussion that happens, right? When something it works in either, the developer's laptop or staging, but for some reason, not working in production. All right. And so, kind of when this idea of Docker containers was developed, right? I mean, what does this really solve for? I kind of mentioned, this scenario of me putting all of my kayaking gear into this container. I can take it anywhere. I can let you borrow it. I can let my son borrow it, but just add water, right? So Docker became the common grounds. It's this water that everything, well, in my scenario, everything floats on. And so what happens is, as long as you have water, it doesn't matter how big that water is. My son can take my kayaking container down to the little pond by our cabin, and he can go in there and he can be just fine. And Steven can take my kayaking box, I can lend it to him, and he's going to take it out onto the ocean, right? Onto the bay or whatever. And he's going to do some open ocean kayaking, and that thing is going to float just fine on that water as well. And so that is kind of the how this Docker platform resolves that argument of confusion of what's really causing the system not to work in production. And I'll just pause for a second here, because we can think about that some more, right? That's kind of a shift. Imagine being able to hand something to somebody and knowing that it will work. It goes beyond just that conversation of something's not working in production. Hey, let's battle this out and get in there. But also being able to hand this off, in development to other people. Hey, I just created this. Can you check it out, right? They throw it in their environment. Maybe they have another application that's going to interact with your application. They can just spin that thing up and start firing off, those integrations and see if it works, right? They don't have to come back and, oh, well, what's the configuration here? Because my system's set up a little differently than yours, and have to have, a 30, 45-minute talk before you can get the thing running. So I think that's that's a very powerful piece of moving to containers. And again, this whole construct is one piece of the puzzle to get us to be able to collaborate faster, to develop faster, to deploy faster, and have less environmental, hardware, etc. related issues, right? So what's the difference between having a Docker container versus, using a virtual machine is this construct of virtual machines, each and every one, it has a guest operating system that can be and has to be configured, right? And it's when configurations drift, things don't patch right. We have one patch version on this system, but somehow that patch didn't take during our monthly patching cycle or weekly patching cycle, and now we have this drift. Always having this drift, and what Docker does again is it creates that layer that I like to call the water, right? Just add water. That layer now is the same. It's an abstraction layer that allows us to build our app and its related dependencies, irrespective of what operating system is this landing on. So we'll take a look at how the construct of how that gets built, and I think this part is actually rather interesting for more than just the development folks, right? So the way that we build a Docker image is we can build it as many layers of this image, and each of these layers is kind of, we basically create a deployment object that, like, this doesn't change, and when you add the next layer, that layer is distinctly separate, and you can lay that on there. And so in this construct, we can actually, for example, have a base image that's hardened, right? Security has taken a look at it, and they can just say, okay, here's our base image where everybody starts, right? So it's also a place where we can kind of govern what's in there, right? And then also with this layered images, there are security tools, right, that can go through each layer and do some code scanning, code quality as well. There's a lot of different things that we can do in this layer, but we can kind of bake these layers in, and you can see it in that there's a writable portion of this container that we can manipulate, and then but under that writable layer, we can have multiple layers that this is my Nginx configuration, for example, right? Here are my dependencies of that container that should not change. So under that, so now we've got those constructs down. We're going to revisit this same diagram, except instead of having to manage multiple versions of different pieces of different components, different operating systems, and so on, now we look at it with Docker in place, right, with the just add water model, and we have our we have my kayak floating on the lake, down the stream, in the pond, heck, even in the bathtub, right? And essentially eliminating this platform-based dependency, because that Docker platform, that abstraction layer, turns everything into the water that we need to float, right, across all of these different environments. So you can see how if everything looks and responds the same with this abstraction layer, when you start deploying code, we're going to be troubleshooting a lot less across this the life cycle of the development life cycle, right, and the deployment life cycle. And so the things that we're going to be actually troubleshooting is, hey, my integrations didn't work with the other application. All right, let me figure out what's going on there. Okay. And I think I kind of covered this, but the results of using this type of a model is that container runs reliably everywhere, right? Even outside of an organization, or even in the space where maybe you develop some component and you want to share it out in the community, or wherever that is. We share that build with the Docker build and so on. You could share images across organizations, and you don't have to know what are they running, right? All you got to know is, yes, they got to they're able to run Dockers, and we can pass them the image. So, and then on the Docker platform, let's say ECS, we can run different apps simultaneously, right? So we can have multiple apps loaded on that same Docker platform, whether it's ECS, EKS, or self-managed Kubernetes. We have the capability to scale out those images, and because we're running on a cluster of servers, that gives us better resource utilization. There's some schedulers and so on those platforms as well, that enable auto scaling and so forth. But to be able to deploy these multiple apps, because you can imagine, in our VM world, right? If we want to make everything redundant, we're deploying at least 2 VMs for every app. There's going to be some resource overhead, right? Running on the operating systems. And then there's that redundancy part. Like, if we're running, 2 of these machines, we're getting 50% utilization off of each of the VMs, right? In kind of the best case scenario for, failover to happen. And running on a single cluster, we gain the benefits of, being able to scale that up as one pool versus many pools wasting, that other 50% utilization. Okay. And then with all of these benefits that come, I mean, ultimately, this is the next step in moving to kind of the concept of, we've all heard that treating your apps or your servers like cattle versus pets, right? This is one more step into, being able to say, yeah, these are all cattle. I can move them from one pasture to another, and they will just, eat the grass and do what they do, right? And so on. So it makes everything start to fall in line looking the same. It's not going to solve every single problem. It's not going to take us, down this is not the complete journey, right? It is a huge piece of it, right? This is one step into making everything into the cattle kind of perspective, and there's still, some work around people and process and rethinking how we develop our applications, right? Because our applications have to be aware of the change between, talking to servers, individual servers and VMs that are important, that are kind of our pets, versus being able to talk to a pool of, hey, they all look the same. I really can't, I can't build in logic to figure out individual instances of apps. I have to look at pools, right? So there's a little bit of difference there. But again, this is the journey. All right, you guys have any questions on that part of it?
Certainly, if you have questions, go ahead and fill out the chat portion, and we can address those both during the presentation and during the next section of the labs. At this point, thank you, Jimmy, by the way. At this point, we'll hand it over to Steve and David to go over how to get logged in and get started with your event hash and event engine, as well as just simply getting started with Lab 1. So, Stephen, take it away.
Thanks, Jay. Hi, everybody. So, Stephen again. Just we're going to go ahead now. We'll switch over to doing the lab. You should have received an email that had both the link to the lab website, which I will share now, and let me get rid of that. The lab website, and then a hash code that goes with that. And we're going to walk through kind of setting up and using that. So we make sure that everybody has a temporary AWS account that they can use for the purpose of doing these experiments without being worried about, paying the bill or having long-term impacts to their account. These accounts have been set up with some basic precursors. That way you can skip some of the initial things, like we've stood up a Cloud9 instance for you. But other than that, there's nothing special about these accounts. You could actually follow these steps in your own account. We're providing the accounts for the sake of you just being able to use the accounts without being concerned about long-term impacts to your actual AWS account. Okay, so assuming you've come to this site, the homepage here, the AWS Containers Immersion Day, we have this left-hand navigation. We'll be clicking through these. We're going to start with that first part, the AWS Containers Immersion Day Workshop Setup. That's what we need to do first. You get this other lovely splash page. Not a lot of information there. You can navigate this site in a couple ways. You can be clicking through on the left-hand nav. You can also click these arrows here if you want to move forward or move back. So I'll just, for the sake of variety, I'll click the arrow because we want to go to the next part. And there's at an AWS event. This is an AWS event. This is a ClearScale and AWS partner event. So you are doing that. You are an AWS event. And we're going to do connecting to AWS Event Engine. So we're going to go ahead and you can either click that link or again, you can click the arrow. They will both take you to the next step. Something that a lot of people get a little confused here. This is a screenshot. And if you click that screenshot, it looks like it does something. You look like you can click on it and do things. You can't. It's still just a screenshot. It's not interactive. It's not a programmed interface. What you can do is above that screenshot, you can actually click this link, the Dashboard Event Engine Run. And when you click that I'm going to click and open it in a new tab. When I click that and open it in a new tab, which I've done before, you'll actually get a live version of what that was a picture of. Now, in your email, you should have gotten a hash. And that hash code is what we're going to end up putting in here, right? So I'm going to grab the hash code real quick. I'll copy that. I'll paste it in here. You have that hash code. You hit accept and log in, right? And once you do that, it takes you to this team dashboard. And that gets you set up where you can get logged into your account. So once you get to this team dashboard, you're not actually logged into AWS yet. You're almost there. We need to click the AWS Console, right? And these instructions, by the way, are in the website. I'm just finding it easier to walk you through it rather than going back and forth. So we click on the AWS Console here. It'll pull up a second window. That second window will say, hey, AWS Console, or copy hyperlink, or do any of these other things that are on here. You want the Open AWS Console. We're going to click that one again. Now you might get an error, like if you're already logged in with your personal account, it won't log you right in. I'll say, hey, you're already logged in with an account, and with that account that you're logged into, please log out. And if you do that, then you log out, and then you go back here, you click the Open AWS Console again, and then you'll get logged in. Now, if it did log you in automatically, you're good to go. Once you're logged in, then you should be in a region here where you can actually go see our Cloud9 instance, which is what we're going to use. Cloud9's an integrated development environment, and we use that because we know we can standardize that when we ask you to install tools or do any work. Then we can be assured that it's the same environment. We're not having to deal with variants on your local machines, right? All right, but let's double check. We're back here, the instructions. We've actually completed all of this. We are now going to the Cloud9 environment. That's this next step. So this is what they're having us do next. So let's do that in the console. To do that, there's a number of ways. If you look down here, you might see Cloud9, you might not. Easiest way is probably to type into the search box Cloud9, and then actually click Cloud9 from the drop-down. And you'll notice that there's already a Cloud9 instance there, and we just need to open it. So I'm going to click that Open IDE to open it. This is going to start up the instance, which can be pretty fast. It can take just a minute, depending on how everything runs. Once you're in here, there's a bunch of windows and a little bit of territory to navigate. So I'm going to take a moment there. But before I do, I just want to make sure everybody's keeping up. So we're gonna go ahead and give everybody just a minute to get to this space.
Stephen launched a quick poll, by the way, just to make sure that people have been able to log in and aren't having trouble. Certainly answer yes if you are good to go, and no, I should say something in the chat if you are not logged in yet. So
yeah,
certainly if you're having problems, we've got our support team here to help you. So please feel free to say something in the chat if you need help logging in or you're missing something. So
excellent. Thanks, Jay. Okay. And there we go. We got. Yeah. So, and if the hex code, there we go. Thank you, Daniel. All right. So once you get that hex code, you get logged in. Go search for Cloud9. Get Cloud9 loaded up. You'll have a bunch of windows. Let's talk through the navigation. You'll have this left-hand side, which is where your code's actually going to be. You'll notice that some code's been downloaded for you. Right, that code is there. You'll have a number of these bash windows open in an immediate window. So just to simplify things, I'm going to go through and I'm going to close. I'm going to leave this top one open, but I'm going to go through and close all these extra windows. You don't have to do this. I like to do it because I like to keep my life simple. In addition to that, I have this bottom section. Could be useful, could not be useful, depends on your personality. I don't want it, so I'm going to hit X. That will simplify my top window, is what I have available. And if I want, I can clear that. And I've just got a nice clean top window ready to go. Okay. So now we have, that would be our Cloud9 environment is up. It's ready for us to do stuff with. So going back to the instructions, let's just go make sure we follow all the instructions. We have our Cloud9 environment. We've opened it up. That's what they're asking us to do here. Here, they pay attention to different windows that can come up. We had some different stuff up here, but we closed some of the windows and simplified it. That's it for this page. We've done the launching of Cloud9. Yeah, don't worry if you only have a niche scripts folder. If you go in to this next step, one of the first steps when we get to the cloning the immersion day repos is to actually go ahead and clone the immersion day repo. All right. So they'll have this Misfits workshop clone would actually get you the workshop. Now, if you actually do have this folder, and I'm not sure why there's some variants, but if you do actually have this folder already pre-downloaded, I have it because for some reason somebody has got my instance. So I don't know why that's happening. Let me go ahead and back out of this one. And I will go pull my own and do this in just a second because I ran into a situation where I was apparently already logged in with somebody. So let me go to the hash code. So if you go in and it asks you to do, hold on, let me go back. If you go in, you hit accept login terms, and it asks you to do either a one-time password login or Amazon login. I typically do the one-time password. Put in your email, and it will send you that passcode. And once I have that passcode, I can log in. It takes a little while to receive the email. Get that going. I'm not totally sure why it's acting different from this one to the other, but we'll just roll with it. Yeah, Ben, I'm not sure if that was typically that hash code, once you put it in, if it's it should be that it assigns you to your own account, not to an account that was already taken. Let me just double check. Huh. I see that several of these are actually multi-assigning people to accounts. Oh, I see why. Let me, before we get too far into this, let me actually switch everybody. Let's not use that hash code. Let me give you guys, everybody, a different hash code to use. 1 second. That hash code, for some reason, is assigning multiple people to the same account. We don't want that actually. So let's use this hash code instead. This hash code will assign one person to one account. Give me 1 second. Yeah, Greg, I think that one's set up for Teams. Yeah, please use this one. So log out and then log back in with when you go to that site that was there. Log back in. You will get challenged with this one-time email passcode and this new hash code. So and that will get us all back onto the step that I'm doing right now. There we go. Starting to see folks joining in. And these are not set up in teams of 3. These are set up as individuals. I am waiting for my one-time password though. One second to get that going. Let me just double check my. I'm going to stop sharing for a second because I need to open my Outlook on the computer to make sure it's not that my phone is having a problem getting my emails. One moment. So I'm still here, just not sharing for a moment. I'm going to go check, see if I can get my one-time hash code here, or my one-time PIN, or it's 9-digit code. It's not really a hash. I'm going to have it resend the code because I'm not feeling the love on getting that code the first time. All right, so I'm going to start sharing my desktop again. So hopefully folks are getting the codes for that new, and this time when you go to Cloud9, oh, there you go. This time I got it right away. So I'll get my code typed in here. There you go. And this time I'm going to go ahead and set my name because I like to set my name. I don't have to do this. It's an extra step. This way, what that does is now this will go away, and this, hey, look, it's got my name on there. But now when I open the console and I go in and I do open the console, right, look, see, there's the error message because I was already logged in. So I'll say, okay, I want to log out. Great, now I'm logged out. I can close that window, go back and hit open console one more time. And I'm back in. And I do have Cloud9. And I will open up again. And this time, I do not expect that I will be sharing with anybody. There we go. I see folks are starting to get in. That makes sense. Excellent. Okay. So again, we have several windows here. This is about clutter and whether you like clutter or not, but I go ahead and I will close all these extra windows. I'll close this window down here. I don't need it. I'm not going to use the immediate window. I just want to drag this one up because I just need a bash window. I could just as easily hit the plus sign and do a new terminal window. That would do it. I might even do that later. I now have this bottom section, which I don't want. It's not useful to me. I'm going to close that out. Notice I only have the init scripts. I don't have the code downloaded yet. That's fine. We're about to go download the code. So if you are, you should be getting into the new account with the second hash, and we will have no overlaps on that one. Okay. Back to the instructions. Now that we have our Cloud9 environment set up, we need to download the code. So that's what this first command here is about. We just need to clone the repo and get the code into our environment. That'll get us kind of, okay, now I've got the code set up. Then we're just going to change it into that folder directory. This is like we're literally changing into that we're setting from being just in the environment to actually being in the workshop directory. That way we can see if I do a list, I can see that I have the scripts section. And then from the script section, I to expand that over here. I go workshop 1. I go scripts. There is the setup script there. That's good because now that we're in that folder, we will go ahead and run script/setup. And this will set up our basic environment. So I need to be in this workshop 1 folder for this script, for this to work, right? And I'm just going to start running the scripts. And we won't walk you manually through every step in these labs. I'm doing this on the setup part because it's not really part of the container learning. Just want to make sure everybody gets their basic environment set up the same. And then we'll allow more breathing room for you guys and folks to just run the lab. That way you're not so focused on me the whole time. I realize not everybody's running on multiple screens. It can be useful at times to have a little downtime to think and read. So we will allow for that. We're just trying to get this basic part. We're following along really tight on this basic part to make sure everybody's kind of solid. We have good environments set up. So this runs for a moment. Gets us some basic, environment variables set up. It does some things like copying code over to our S3 bucket. This is setting up our instance profile for our current instance. Makes that all good. All right, at the end you'll have this. It'll say success, profile associated. All these things will have completed, and you'll get your command prompt back. It'll show up at the bottom of the screen. So then you're like, great. I've successfully run the setup scripts. That's this section here, number 2, on the cloning immersion data repository. That gets those scripts run. Once those are done, we're going to run some environment variables and do some default config of the AWS CLI. So again, I'm just going to copy that section. We do this because we need to interact with the CLI. We're doing things like double checking what account we have. We're pulling the region from the metadata on the instance. And then we're setting that information for us to use later on. There you go. I want to see that output. This one will have you in Ohio. You'll be, by the way, now that you're on that new hash account, everybody's working in the Ohio region, which is good stuff. All right, so now we have that going. We have one more basic setup step, which is going to be this create the SSH hash key. You can either click that directly or click the arrow. Both of those work fine. We're going to use SSH keygen to make that happen. So I'm going to copy that command. Come back to our Cloud9 environment. I'm going to scoot this up to the top of the screen because I feel like I'm making y'all look at the bottom of the screen. Just going to paste keygen. It's going to ask for stuff. You just hit enter 1, 2, 3 times. it generates the key for you. We just need the defaults, so we don't need anything special. So that's using the key gem. Once we have that created, we're going to add that key, which has been placed here. We're going to add this key over to our EC2 key pair. That way we can use it later on. So that's why we're generating the key. You shouldn't get an error. It should work with this first command. There we go. You'll get back, hey, look, the key name is Mythical EKS, which doesn't make total sense for us, but that's the name of the key. So we don't need to run this next command. It's fine. So you're going to run the sysgen, hit enter 3 times, do the import to EC2, and now that key will exist in your environment. Okay? All right. Once we have that, so we need to make sure everybody's clear there. That's the last of the setup steps. The next steps, you're actually going to get to try working with container technologies. So I just want to make sure we've established this here. Now's a great time. If you aren't set up, your environment isn't working as expected, or you have any concerns, by all means, please leverage the chat. Let us know. See if we can get you any help there. All right. This next section is Introduction to Containers in Docker. And it's really, this whole section is really a lot about using Docker and getting comfortable with Docker, making sure that you're familiar with some basic commands in the Docker system. So, we do things, and I'm not going to run through these steps live. I just want to describe some of what you're going to do, and then I'll be quiet for a little while. We might chat a little over here, but we'll let y'all engage with the lab directly without feeling like you're following me the whole time. But first thing to do is we get to know Docker a little bit. We make sure that you have a Docker image there. The Docker's up and running. You do some basic things like you pull an image. You read a little bit about what the commands are. You can see your images. Once you pull the image, you actually run it on your local machine, so you get the sense for what does it feel like to just run a container on your local machine. Let's make sure you've done that at least once. And this one runs it as a daemon. You could run it in process in the window if you remove the -D. But in our case, we want to run it as a daemon. That means that it'll run in the background. You'll be able to do other things in that window while you're doing that. We do things like Docker PS to see what's running, what's going on. We can actually, curl the localhost machine on port 8080 to make sure that we can access that container, that we get a response back from it, right? We go through, we check the logs to see what's happening as we do that. We actually log into the container. So you can see, hey, I'm going to log into the container. I'm going to run the bash shell command once I'm logged into it. And then I can poke around. You can run ls and see that, look, it's a different file system than the one I was just working with. You can pick some of your other favorite commands to see what's going on in that container. Then we make some updates to the code there, and we exit out so you can see that you can actually make changes to that container. You might even do a curl command after you've done something. Well, here we're just looking at the container. We're just looking at the code, but you could change it and do stuff. It's up to you. Then we leave the container and we actually stop and check out what happens now that I've stopped the image. What do I do? And then we go through removing the container, removing the image, all that stuff. Next, you go from just experimenting with the basics on what the container is, how to work with Docker and what's there, to actually going through and trying to build your own container. This you'll leverage some of the code we have. There's a Docker file that you're going to create, and then you'll start building out what's in there. Understanding that the Docker file can build from another image. That's when you do this from Nginx latest. You're pulling an existing image and you're adding stuff to it. So I've got my basic image, and I'm going to copy a file to that image so that I can change things and make things a little different. That's not going to run right away. That's creating a file that will do that. Then we create the index image that we want, and we add some content to it. This will give you a chance to see what doing that is. Now I've got a new container image. I want to build it. I want to see what the history of the build is and see what layers are involved, and then try running it again and see when I do that 8080, it no longer gives me the default Nginx index page. Now it gives me the content that I produced. Instead of the default content, it'll have, hey, we've added our own custom content to the container. And then you keep playing with it, right? Like you're going through here and you're looking at it as you're making changes. You remove that image, you work with that a little more. All of these are about getting familiar with what it means to make these changes, to add things to the content, and then we remove the Docker image when we're all finished. So with that, I'd like everybody to try running through this lab. We'll give you a little time to do that content. So I'm going to stop sharing for a minute because I want y'all to focus on your screens, not on mine. But go ahead and take this time to run through this Docker lab.
Again, in case you didn't hear, we are letting everybody just kind of work at their own pace right now. At the top of the hour, we'll do kind of a pulse check and see where everybody is in these labs. And then we'll wrap up this section and go to a quick break so people can stretch their legs, grab coffee, etc. And then we'll come back for our second portion of today's workshop. But again, if you do have questions, concerns, feel free to use our public chat and our team will happily and readily jump on those as soon as possible. All right, everybody, we're at the top of the hour, so I'm going to go ahead and launch another poll. Certainly, if you're close to finishing, feel free to take your time. But we're going to probably wrap up this portion here in about 5-6 minutes, and then we'll take our 10-minute break. So again, if you are having any challenges or need a little bit of advice on how to complete this, certainly let us know in the chat, and our team will help any way we can. All right, Stephen, any closing thoughts here in the next 5-6 minutes as we kind of prepare for this next lab?
Just that this first section is really all about getting to know Docker a little better and getting comfortable using it in Cloud9, because that's the environment you're going to be working in. So just giving you a chance to get a little exposure to leveraging Docker and leveraging it on a Linux-based system. That way, as you move forward, those commands don't feel alien to you or awkward. They're something you've had some exposure to. So hopefully we successfully accomplished that, and that'll set you up to be ready for the next learning, which is more focused on some of these higher level services that we offer at AWS.
Excellent. And I am about to spin up another poll beyond this one just to find out how you'd like to have these labs performed. Certainly, every time we do these workshops, we get a different variety of answers, whether it's working in silence or completely watching AWS perform the labs themselves, or just letting you kind of run and go, and we kind of chime in about the different pieces. So I'll be providing that in a second, so we can craft the workshop to how you guys see fit. So I'll be launching that in just a minute. All right, so that poll is also posted. Certainly, if you hate the silence and it's deafening, you can always select watch AWS complete the lab in its entirety, although some find that distracting as well. So we're certainly looking to do what we can to make sure that you guys get the best experience possible out of this workshop. All right, after a good portion of responses, it looks like a blend of both AWS working on the lab as well as silence seems to be kind of the best approach. So certainly Christian will utilize that method when we get to the labs after the break. We are going to be wrapping up and taking that break here in just a minute. I will put up a 10-minute countdown clock so everybody knows exactly where we are on the time. And then when we return, we'll jump in with Greg Fina as he talks about this next section. And then Christian Tamaldan will walk us through the next set of labs. So again, if you're close to finishing, feel free to work through the break. And if you have questions, again, utilize the chat. We are definitely here to utilize that chat. So thank you. All right, I'll be moving my screen to a countdown clock for everybody, and we will be back in just about 10 minutes. So looking forward to continuing the workshop, and please feel free to get up, stretch your legs, grab some more coffee, and we'll continue with these great labs and presentations from AWS and ClearScale when we return. All right, everybody, welcome back. We're going to be launching into ECR, ECS, and Fargate. Again, thank you for going through the first lab with us and certainly posing your questions within the chat. Again, reiterate that this is a very much interactive workshop. So, when you do have questions or you want to talk about your instance, your use case, we do have private chat available as well with our AWS and ClearScale team. But at this time, I'm going to pass it over to Greg Fina, who will walk through ECR, ECS, and Fargate.
Hi, good morning, good afternoon to those of you on the East Coast. We're going to just spend a few minutes before I turn this over to Christian on the lab to talk about ECR, ECS, and Fargate. All of them have to deal with containers. If you think about containers, what you just did with Docker, a trivial container stopping and starting, you can do with Docker. But when you think about trying to orchestrate containers at scale, you need a container repository, which is what ECR is. And once your containers are in ECR, you can launch them. And if you think about an application at scale, most of the time you have multiple copies of your containers running so that you can load balance across it. And that's what ECS or Fargate provide. ECS is an AWS developed container orchestration service, which actually predates Kubernetes. And Fargate is a way to run it without having to manage the underlying infrastructure. So I think I've covered this slide already because I jumped ahead, but let's just take a second to deep dive on ECR. ECR is a fully managed container registry. That means you don't have to worry about the underlying storage, the capacity, the APIs to access it, the underlying compute. It's secure in the sense that part of what it does is as you post containers, it does scan them and look for vulnerabilities. So it does provide you security on your containers as you're loading it in. The second thing is, as an AWS managed service, we provide the security for the service, all of the security controls, the security endpoints, the compliance with third-party regulations. It is built to be highly available. It is a region-based service. So if you launch ECR in US West 2, the service lives in US West 2. If you launch it in US East 1, the service lives in US East 1. We have several customers who will launch it in one region and pull containers across from another region. It's perfectly fine. We also have customers who will basically load up two ECRs, push containers to them, and pull them down in region. It really comes down to how you want to execute. And then the last thing, it does simplify your workload. It makes it pretty easy. You push a container in with Docker, you can pull a container out with Docker. So the commands you're familiar with from using Docker, you can use to leverage ECR. I'm not going to read the definition of that. But really, when you think of ECS, you're really thinking about AWS's own orchestration system. It predates Kubernetes, and it was a way to basically allow our customers to leverage containers at scale with some orchestration. It provides the concept of a task, which is really the container, and it allows you to access services like our load balancers. It allows you to access other services through your task configuration. It comes with the API, so like every other service that we have, it's all coordinated through an API. That API allows you to launch tasks. It allows you to restart tasks. If you run it on EC2, you're responsible for maintaining the underlying OS of that EC2 instance. When you run it on Fargate, we maintain that for you. So I think Fargate, to some extent, if you're looking for a simple way to adopt containers or get into containers, I think Fargate is really that entry point, because you don't have to worry about the underlying EC2. It's elastic. It integrates with all of our products within the AWS ecosystem, around load balancing, IAM, CloudWatch, communication with database servers. So it really simplifies your experience coming in. And now what I'm going to do is, if there are no questions, I'm going to pass this over to Christian, who will take you through a lab of using ECS.
Cool. If there are no questions, I can take over. Thank you, Greg, for the baton pass. And good morning and good afternoon, everyone. I'm Christian Temeldon, and I'll be taking you guys through the labs for ECS as well as Fargate. Let me share my screen here. Okay. So let's see. All right, is my screen being displayed?
Looks good on my side, Christian.
Awesome. Thank you for the confirmation, Jay. All right, so I did take, I appreciate everyone voting into the polls. We will continue with the Steven style, I like to call it, where I'll go through each of the labs, talk about each of the key pieces you want to take note of, and then let you guys work. And for those who wish to work in their silence, feel free to mute this workshop by going, if you're in Chrome, so I think most people will be using Chrome, but if you go in Chrome, you can actually click here and set the sound to mute. That way you can also put on your music of choice and work through the labs yourselves. And then lastly, for those who want us to walk through the labs, after I do each lab, for those who wanted to have a blend of silence, I'll just silently work through the labs on my screen. So feel free to just follow along in big marker as I go through the labs myself. I won't be talking though, just to give a bit of silence to those who wanted to have that blend. But I will be completing the labs as well. So yeah, once if everyone is ready, I can deep dive and let's begin. All right, so everyone should be here in the Containers Merging Day workshop. If this is too small for me, let me know. Feel free to use the chat. But yeah, so the idea is I have it here for those who wanted to kind of follow along with me as I go through the labs. But here's the first step, which we've started along with Steven. We've set up our lab. We have our understanding a bit of the basics of Docker. Now we're going to try and see how we can use ECS as well as Fargate to launch some monolithic app in that service, and see how we can work around and making everything eventually into microservices. All right, so let's do a quick jump back into Cloud9. I increased the text font to be very large so it's easier for everyone to see. For a quick update, we'll be using Workshop 1. And inside here, the key folders you want to take note of are app, as well as the CFN output. So we do offer many places to find information about the infrastructure. One is called CFN output. In here, you'll get the key things like the application load balancer in use in this architecture, as well as the DynamoDB table. And of course, our S3-based website that we'll reference and show. So right now, if you guys can get this URL, each of you should have your own. If you copy that and enter that into your web browser, you'll get something not with the mystical misfits, but just like the splash page with the header at the top. So what's going to happen is we're going to add these little guys and show them on the website through ECS and Fargate. All right, so let me go through a bit of lab 1 here. If everyone is feeling a bit comfortable with what they see. So the idea is we're going to deploy a container with our misfits and then deploy them using ECS. This is a very large monolithic application, meaning everything is contained in that one code base. And then eventually, once we see it all working, we'll eventually take it all apart and make them into microservices. One challenge at the very end of this lab section is we'd like to see if you guys can separate each of the key, I guess, functions of the monolith into its own container. And then that'll show you how you can take a monolith of your own and separate into key pieces of your application, and then have those scale independently based on load of what's happening there. All right, so let's go through the instructions for lab 1. So I'll increase the size of my Chrome window here so it's easier to read. Here's a sample architecture of what we're doing. Essentially, we have things located in S3, set up with you guys earlier with Steven. We'll be using CloudWatch to contain the logs of our containers. ECR, of course, as Greg was saying, is our registry, which will contain our images. And right now we're in our, we're usually in Cloud 9, which is the I guess I like to call it my Windows machine, or my MacBook in the cloud. I stopped making my dev environment, my personal dev environment, in my Mac, because it's just easier in Cloud 9. So maybe moving forward you'll start using this more, only just because it's just made a lot of things simpler. And of course DynamoDB, which stores information about our misfits. All right, so just walking through the steps of the lab here. We have a bit of understanding of what a Docker image is, as talked about by Stephen and Jimmy, as well as what you guys probably did earlier in the setup, where how do we set up containers and setting the latest tag and having the latest version of the container. And as we move forward, you'll see that we're trying to build out the code base into its own monolithic container, and the steps here are. We'll get you through that. One thing is, if you want to kind of jump ahead, there's a thing called the Finder Docker file, because it'll have you try to challenge you to kind of code out what you need. So if you want that challenge, feel free to do so. But for the sake of time, the final completed Docker file, just to see how everything works, is here. You can copy paste that and run. Moving forward, it shows you how you would create the container, set it up properly, and then you set up all the key components like integrating DynamoDB, testing out your container, seeing if the code base is working correctly with that container running locally on your Cloud 9. And then if that all works, we can move forward and upload that container image to ECR, which is here. And then you'll see it uploaded, and we can move on from there. Because after that, once we push it up to ECR, we're ready to deploy it into our ECS task, our ECS cluster. All right, with that, I'll let you guys go, but I'll leave my screen open as I'll go through the steps for those who wanted to watch, and for those who just wanted to work on your own, you're probably just off. I'm talking to an empty audience, which is fine. So yeah, feel free to just kind of check back and forth with the chat, and yeah, we'll see you at the end of lab 1. Don, the bucket name you can also find here in, I believe, in CFN output, which that should be site bucket. Oh. Were you able to follow along earlier with Stephen to set up the environment?
Yeah, if that bucket name is missing, I would go back to the setup script. I would say something probably went wrong there.
And I think Maria's audio has dropped. Can anyone let her know that the website is readily available anytime, please? All right, I'll do a check-in at around 10:40 a.m. Pacific time to see where everyone's at, and then we'll see about moving to lab number 2. All right, it's 10:40 Pacific time. Just doing a check-in on everyone. Is everyone okay with lab 1, or do you guys need more time?
I just sent out a one-on-one message to Don S. Is he okay?
Okay, no worries. Yeah, feel free to take your time. I just wanted to get a feel of how everyone's at.
I launched a poll for us as well, Christian. So
Okay.
it looks like probably half the group still needs a little bit more time. So certainly feel free to work in silence, ask questions. If there's anything that you're kind of getting stuck on, let us know. Otherwise, if you have questions in general about Fargate, ECS, Docker, any of the above, feel free to pose those, and we can have what we consider couch talk right now to fill some of the silence as well.
Of course. No, definitely good points, Jay. All right, so Don is good. Thanks, Tim. Also, thank you, Stephen. So yeah, I'll give everyone about 5 to 10 more minutes. I'll check in around 10:46 Pacific time, and then we'll see where everyone's at. All right. Is everyone up to speed? I believe, Dawn, since you had to do a little script rerun, you might be a little bit near the end of the lab. Okay. All right, I'll give you a little bit more time just for the sake of what? Oh, the local host part. Alexandria, yes. Are you good? Connection refused. All right, let's do a quick debug together. Which means you are at this part.
You might have published the container without doing the final container. It's kind of hidden in there, and a lot of people skip that step.
Yes, correct. You're right,
So
Stephen.
if you want to review that one with Christian, I think that likely their container, when you ran it, it should actually stay running in that window that first time you run it. If it runs and it seems like successfully concludes and then goes to the next line in the command line, then you didn't get the latest, the final image put together in the Docker file. So I don't know if you want to shoot that off real quick, Christian.
Yes. No, excellent point, Stephen. So the lab likes to give a little challenge to those trying out this using ECS. However, at the very first one, right, we had let me see if it shows it. All right, so it asked you to do a Dockerfile.draft. It has a couple to-dos. This was the challenge: is what commands you need to have it run properly. What we do in the lab is actually how to have a hidden button that strangely doesn't show. It's a hidden button. So if you click this hint here, if you guys can see the screen I'm sharing, if you see this hint here, this is the completed Docker file you'll need to have a running service. So if you just copy this, and in your actual Docker file, that's not .draft, right? So you'll use these commands to properly create the container to try. Let me see if I can show the file structure as well. All right. Yeah, so you'd have a Docker file.draft, and then if you paste this inside and save it, one of the commands here would have you move that Docker file. Here it is. One of the commands here would have you move that Docker file.draft into a working Docker file. And then that is what's used to create a working container for you guys to try. All right, well, I'll give you guys a bit about 5 to 7 minutes, if that's working for you. Sorry, to get that working for you guys. And then, yeah, once you get this working, the rest of the steps are pretty much copy paste in terms of the commands to run. Because once you have this working, you can see the sample output from your curl command. Oh yeah, I'm not running. Sorry. Do that. If you get a sample curl, then the next couple steps would essentially just have you upload this container into the ECR repository for use by the next lab. All right, just 5 to 7 more minutes for the group here, and then we can see about starting lab 2, which is a bit of understanding the key element of running things in ECS, which is what we call tasks. Wonderful. Yes, once you update the Docker file, please do follow the steps from that point forward. So that should be this one, and then the build the monolith service, and then Then from there, if you run the one that shows table name with the DynamoDB command inside, that should have a working container for you. Done. So you also have to run this table name command as well. And that's interesting. Oh, there's 2 periods in the DynamoDB for some strange reason. Why is that? Let me see here. So in my environment, my table name. Invalid endpoint. Correct. And let's see if it copied the table correctly. So run this command. See if it detected the table name properly. Awesome. All right, Ben, you are good to go. So if the table name, if you echo $ table name, it should show you something similar like table-mod. You're supposed to the Docker file you wanted to, yes, correct. It's workshop 1 app monolith service Docker file. Cool. So all right, that means the command here is working. Did you guys also build the monolith app after changing the Docker file? So that should be this one. Sorry, let me paste that into the chat. And then from there, then from there you can run the run command and you should be good to go. It'll be very quick. All right, when you guys, if you guys get a successful run, let me know, and then we can do a quick jump to the near end so we can get you guys running on lab 2. No, not a genius. Come on now. Abhi, yes. Question. Yes, correct. It is actually a JSON blob that has no carriage return, so it looks like a bunch of gibberish, but it's actually a structured file. What that looks like is something like this. That's what the output is. Yes. All right, awesome. Welcome back. But yes, someone had their hand raised. Question. Happy, yes. The 2 dots are still in Dynamo URL. Why is that?
It seems like an environment variable not set or something.
Yes. Let me see here. Where does that reference? No, it should be here.
If you're getting the environment, if you're getting the Dynamo table with the 2 dots, what step are you on? Like where are you? Like where are you guys getting that URL from?
Yeah, Abby, what was the last command you ran, or at least the last few commands you ran before this happened? Let's see. Fine. What is in here? The 5 or 2. And don't do that. So we're using the Bodo client, but you just handle that for us. What is this? Why is there a join for this in the YAML? That's gibberish for old code. So they ran the command that's supposed to allow them to run. Okay. All right, Abby, let's do this. Let's do a manual move. So let me do this for you. Let's go to, you should have a cfn output for yourself. You have a Dynamo table here. What you want to do now is, instead of having, well, we can always set it. Yeah, we can manually set the table name to your, let me see how we can do this for you, to this. So we'll do that. I believe it's, or no, let's just do a, and that should just be, oh my. See something. I don't know what the your full Dynamo table is, but that should just be with service. Yeah, that should get, yeah, so just replace that table mod in there with the actual value and see if it works. All right, just questions for everyone else. Everyone else is good to go. Cool. If silence usually. Cool. All right, Mark. Have fun. As always, you can come back to this until 9 p.m. Pacific if you wanted to continue. And then moving forward, the website for the labs are readily available for you if you wanted to try it on your own account. Yes, please push the image. You'll need this for the task and understanding how ECS works. So once you're at that point, Don, you'll push it to the variables will have you push it to the repo for the environment. And then when you're there, you're at the checkpoint. Let's strange that there's 2 periods. Why though?
Yeah, I think the 2 periods, like it's gonna be missing. I think it's actually probably the region that's missing. It's that URL. I think usually is DynamoDB dot the region dot Amazon.com. So it's probably the region variable that's not set.
Oh, you're right. Yeah, let's check that. Oh, you're right, Stephen. Let me see. I'll just do this real quick for the group. So yeah, welcome to a crash course on DevOps. There you go. Right. Yeah, let's do a quick containers. Where's that region? It gives it, no, it's in the setup, correct? Here we go. Nope. That's what I want. So let's do this. So it's called, okay, that's what it was. Let's do this. Oh, go there. If that does not show up like this, then definitely there's something missing. All right, so it looks like, yeah, correct, Stephen. Awesome. Virtual high five, man.
Sweet.
All right, cool. Abby, do you mind if I move forward with the group? And or I can give you about 2 to 3 minutes to catch up. All right, yeah, I'll wait then 2 to 3 minutes, and then, but I'll prep up the lab for the. Oh, okay, cool. All right, everyone. So if you haven't gone on ahead, thank you for waiting, and I hope you enjoyed the quick deep dive in how DevOps works. So yeah, so just to quickly talk about Lab 2, and then I'll let you guys go. So Lab 2 will help introduce you guys to a key component of ECS, which is tasks. So tasks are essentially the Docker run command just in ECS. So tasks are defined with things called task definitions, and that's where you dictate, what image to use, what kind of specifications you want the task to run in. And this lab will get you through all of those pieces. So as you move forward through it, you'll set the image that we've pushed in ECR, and then you have some CloudWatch logging settings, which is what's used to ensure that our container is logging properly, and you can act on it from a DevOps and operations standpoint. And then after you have the task definitions set, you'll essentially start and run a new task, and that's running your container in ECS. And then for this version, for this part, we'll have it have its own public URL, or sorry, public IP, and we can access it directly through its public IP. And then you'll see how that can work when you access a container directly. And then after that, the next lab will have us set it behind an ALB, which will then prepare us to eventually separate this monolith into microservices. But yeah, after that, with that, I let you guys go, and then I will, as like the previous lab, I'll go through these steps on my own, in silence, sadly. So feel free, if you've been following along, feel free to jump back to my screen share. Otherwise, off you guys go. And as always, feel free to have any concerns or questions in the public chat, and our team is here to answer them and help out. All right. All right. So for let's see, Don. So if you are viewing my screen, you should have two, right? Inside, if you click here, you should get the images that you've pushed. And then for Alexandria, let me see. If you are in, you are at the part where you wanted to modify this, correct? Which is the task definition. And then you should have this container definitions button here. Or if you, let me see if I can do this real quick. If you go here to click on the container, there's a button. Inside is where you get to select the image that we pushed earlier in lab 1. And then in here is the, I believe at the very bottom is the AWS logs information. It's pre-populated because this infrastructure was launched for you, but that's where it would be located. So when you update your image for the task definition, it'll show up here. Yes, correct. Don, you are, yep, right spot. You're good to go. So yeah, moving forward, before I forget, Don, inside there, right, the value you'll use is going to be this image tag latest and copy URI. So this will get you what you need for the task definition that you'll update in the next steps. And then for Alexandria, are you okay with the explanation for where the AWS logs configuration is, or are you also looking for where do you want to see the logs after you've launched your new task? Okay, yeah. So the configurations are in here. So if let me show you real quick. Task definitions. This mod task. Let me go ahead and create new revision. If you scroll down, there is a container definitions. If you click this one, this is where you select your image and you can put in. And then at the very bottom, there's some configurations for logs. Yep, you're good to go. It's default. And then from there, you can launch and you'll get a public IP when you create a new task in your cluster. And then you can try it out and see. Yeah, you'll get something, you'll get the gibberish JSON blob when you do a curl on it. All right, I will check back in at around 11:25 Pacific time. I think that's enough since you after running a task, it's essentially checking to see if it works. And then once we're good to go, we can start modifying our monolith and we get to see the web page in a true form in the next lab. All right. If everyone is, it seems Alexandria is up to speed, and I think Don is also probably there as well. And everyone else is ready to go for lab 3. Yep, silence is usually yes. In this case, all right, just a quick dive and understanding what's going to happen in lab 3, and then I'll let you guys go, and then of course I'll run through the lab myself, and then we can always ask questions as we go along. But yeah, lab 3 will now introduce you to the application load balancer. The application load balancer is one of Amazon's newer load balancers. Originally, it was just a standard load balancer. This one is more specific. So if you've used Apache or Nginx in the past, it works similar to how pathing works in those two applications. And now it's just a load balancer / service with those capabilities. So you can do pathing. So for example, /misfits, and have that point to a different container. Or as you'll find out in lab 4, we'll separate the like feature of the monolith and have that separate into its own container service. But yeah, so the lab will get you set up with a application load balancer. So right now, if you go and see the CFN output.json, you should have a load balancer DNS in there. And if you enter that into your web browser, you get the defaulted Nginx container that's running. So we're going to eventually change this into the backend service, which is what's the JSON blob, and that's what's going to power the S3 based website. So the steps will have you go through, modifying the cluster, creating service, updating the tasks, provisioning it with the new image we've pushed since lab 1 and 2. And then from there, once you have that set up, you'll then just go to the bucket website on S3. It's also available in the CFN output.json. And then you should be able to see what I had earlier at the beginning of this lab, which is a working website that you can interact with our mythical misfits and adopt them, like them, and whatnot. And with that, let's go. And also, so the difference between this lab is also an introduction with services. So services essentially is let's call it a manager of tasks. If you've used traditional AWS architectures, which include auto-scaling and the original ELB and regular EC2, services is essentially that sort of mechanism, right? Where you create a service, it handles when to remove a task or update a task or load balance task or add or remove tasks. So this service would be akin to a auto-scaling group in traditional AWS terms. But with that, yes, I let you guys go and try it out, and I will do it on my end in silence. And as always, feel free to chime in on the chat for any questions or concerns. All right. If everyone followed the instructions in the lab, this one's actually pretty quick. Well, quick in the sense that there's not much to do aside from seeing how ECS will deploy a task for you once it's inside a service. For me, it took about 5 or 6 minutes for it to do the deployment. Likewise, it should be around the same time frame for everyone else. And the ultimate test is seeing the S3 based website with our mythical misfits, where you can see profiles like the profile as well as adopt the misfit as well. If anyone has any issues getting to this point, feel free to drop in the chat. I'll give about 2 to 3 minutes extra, and then we can move on to lab 4, which is now separating our monolith into microservices by pulling out the like service and having that as its own container. Okay, Alexander, you're not seeing the misfits, but you have this the header, correct? So the header should be there, but you're not seeing the misfits. No, you should be using, so to see if this is working, you should be using the IP for this point should doesn't really matter. It should just be the bucket for your website, which is located in here. Everything's handled by the ALB at this point. So what happens is, as long as your ECS task has deployed correctly, so you can see in deployments, you should only just have one after doing the task update, or sorry, the service update as part of the steps. So once that's done and complete, you should only have one deployment that's primary, and then only one task, which is our new task. Yes. Okay, cool. Yeah, from there, it should just run as is, like this. A good way to check is to take the, let's see, is to take the ALB and see if you can do /misfits on it. So the ALB should be, let me see here, project mod. You want the load balancer DNS, right? Put that into a browser window and do /misfits if it shows the JSON. Oh, okay, wonderful. So you did deploy correctly. Did you update the task, or sorry, did you update the deployment with the latest version of the task by chance? So that should be, let's see. So when you do an update on the service, right, there'll be a revision, and that should be the latest. And that should be revision 2 if you did not add any additional containers. And then from there, just scroll down and do next step and deploy. If not, it's most likely still using the image for the Nginx. How can we check? Let's see if we go to task. Group is there. Where is that? So if you go click on the task and the image is not our ECR image URL path, that means it's still using the Nginx container as part of the task definition for the service. 404 not found, and that's for the ALB for this, right? Interesting. Okay, so what does that mean? Alexander, do you mind checking your ECS task for me? So from the cluster, you can go to services, our this giant monolith service, and then you should have a task, right, that you just deployed. If you click on the task, can you check to see if the image is our ECR image? It is. Sorry, I wasn't looking at the chat. Oh, is it Nginx? Most likely Nginx latest, yes. Yeah. So for that one, what you can do is just quickly go back to our cluster here, right? And go back to services, and then back to that service, and then click update. You'll have this configure service, and then it says revision should be. Hold on now. You have to select the task definition here, and then the revision should be the latest, right? Which is the one we launched with a manual task earlier in Lab 2. So for everyone who's been following the Lab, a revision should be 2 for latest, or whichever latest is, which is the one that has. Interesting. If it's set to latest on the revision number. All right, so let's do that. Okay, good. And then go next step, and then just launch it. So it should go next step, just next step, everything. Yes, next step to everything. And then when you do that, go ahead and update the service, and then it should be using the updated task definition with the reference to our ECR image. So I'll just do it for mine, it's fine. And then this will take about an extra 5 minutes, sadly. That's how it works. Otherwise, the other one would be, that should be it. If the task definition was properly updated with the ECR image path. So if you did the lab earlier and then had a working container with a public IP, then this will get you working and running. And then let's see. All right. So once everyone's at this point, okay, you did have that. Let's see now. So when you update it, still not working? It's all good. Okay. Yeah, got it. We're actually near the end since we're about to run out of time, since we're until 12. But you are still welcome to work on the lab and debug a little bit until 9 p.m. Pacific. I'll just talk a bit about what's going to happen in the next lab, Lab 4, and then a bit about EKS, and then we'll have a couch talk with everyone if you want to hop on to voice or message any questions. Questions like, why should we use Fargate over EC2? And I'll give my inputs or concern, my experiences, and anyone on the team can talk and share a few things. Yes. Yeah, that one is fine. That is because the so for just to quickly get everyone this you get this issue because the role we have for this sample account or this temporary account does not allow you to change the auto scaling for it, which is okay. Behind the scenes, ECS will do it for you, so it's all right. And if you had that error when you were doing the update to the service, right, which is this, before I forget, which is next step, and here, just go ahead and leave it like this. If that's where the error is coming from, there's that whole role issue, but behind the scenes, ECS will update your task for you. So go ahead and keep that as a note. But yeah, so yeah, that's the end of that lab. You should have a working S3 website where you can view and adopt your mystical misfits. And then, quickly to talk about it in lab 4. Lab 4 is essentially taking our giant monolith application we've been working with for the past 3 labs, and then start separating out the pieces of the Python application into its own containers. There is a sample one called the like service, which will separate the like service from the monolith, and then show you how you can separate it out with the application load balancer. So like moving forward, if someone was trying to click on the like button, it'll just send it to the container service of the like service. And the steps it's a little bit confusing. It takes a bit of reading, but if you just follow the steps directly, you'll see it work. And then at the very end, the lab will have you set itself a challenge, which is, can you separate the other pieces of the application into its own container service, which is a good exercise to see how you can do something similar for your own monolithic applications. And then it also gives you experience in seeing how the ALB works and how you can have multiple destinations in your ALB. So you can always, separate these and make microservices as you move along. And this also gives you a good path on how you might want to do a migration strategy with a giant monolith. You can only start doing it piece by piece instead of having to do a giant one-time, big time, I like to call it, which is always a chance for failure. And I've experienced a lot of issues in my past DevOps life with that, like that, when it's just one time, big time. So, you guys get to feel out and experience how it works, and also gives you at least a structured example of what to expect. Likewise, since this lab is still open until 9 p.m. Pacific, we do want you guys to also try out the EKS lab, which is essentially a series of 4 additional labs that shows you how to do the same monolith but in EKS, and it gets you through, how we've integrated Kubernetes into the AWS infrastructure, and how you guys would be able to interface with Kubernetes moving forward. So we do have a few tools in here, things like our EKS Cuddle or EKS Control, depending on how you like to pronounce it, which is a more streamlined version of managing these clusters in AWS through the CLI. And then it shows you the equivalents of what we did earlier in ECS, which is deploying our monolith again, but on Kubernetes, which is in Lab 7. And of course, understanding how you would build and separate out these microservices into its own Kubernetes based cluster, or how do we call it? Well, they call them pods in Kubernetes, which is the structure of how we separate containers and have them independently from one another. But yeah, that's pretty much near the end. I will now relinquish the microphone to the entire audience as well as the team here. We can do a bit of couch talk if you want, but yeah, thank you guys for joining. I hope it was fun, and I hope you guys join us for the next session. And also, yes, I throw it back to Jimmy to talk about what ClearScale also offers in the container realm. I've worked with them in the past. They've done very good work for the time I was working with them outside of AWS.
Hi, everyone. Jimmy here. I just wanted to put out a few of our offerings. For today's participants, feel free to reach out to us if you want to schedule kind of a dive into a demo of an integrated solution, right? So with a CI/CD pipeline running on an EKS cluster with auto scaling, and then be able to view, what do the metrics look like when they hit Grafana for monitoring, right? And you'll have some time for dedicated Q&A to cover some questions that may be unique to your organization or just your particular situation or your function at the company. And then above and beyond that, if you would like to play with Kubernetes yourself, we could do a 2-week engagement to do a quick start. We'll gather some requirements with you, create a design that's relative to your use case, have a automated deployment of the cluster, set up a sample application through a CI/CD pipeline, and that way you can use that as a reference, and that's deployed in your environment. And you can use that as a reference to continue building. And this is more, I would say, for R&D or development environment. And if we are, if you want to go into or walking towards a production type deployment, then we highly recommend going with best practices, deploying a proper landing zone, right? And this is a governed set of accounts that have different functions per account, and together provide the controls needed to operate a system in production. So, and this will be a multi-environment landing zone. We'll do the architecture design for how things should be set up, the particular security controls you want in place, centralizing logging, those kind of pieces. And then we will create some IAC automation, whether through Terraform or CloudFormation. You'll get some EKS environments stood up, and then we'll help you prepare one of your applications, right? So maybe you got something that is not containerized. We can take that app, call it a pilot app or something like that, and we will containerize it, create the CI/CD pipeline, and then again, that's can be used as reference to complete the containerization on top of a fully fledged infrastructure landing zone.
Perfect. Thank you, Jimmy. And that leads us to our AWS survey. Your feedback is certainly extremely valuable as we craft more of these workshops in the future and try to refine them and make them a better experience moving forward. So I will be pushing out a pop-up onto your screen right now. It's a quick 60-second survey. If you would just take a moment to fill that out while we jump into the Q&A portion, that would be fantastic and certainly help, again, with all the content, with the presenters, and everything else, the platform that we're using today. Any feedback is very much welcome and appreciated. So. And finally, that leads us to our Q&A portion for our presenting team. So certainly if you have any questions, post them in the public chat and we will get to them. Otherwise, I do have a handful of questions here that we've gathered throughout today's workshop, starting with why are we using Cloud9 in the labs today? We may have addressed this, but I'd love to circle back on that one. Stephen, I believe Cloud9 was part of your area.
Yeah, no, so Cloud9 for us offers a great way to simplify the development environment and create a standard and consistent way in which we will develop and use a resource. In this case, we're using it to allow us to know that, hey, there's not going to be something strange about the configuration on the operating system. When it has Docker, we know it has the right version of Docker. We know that it has the AWS CLI installed. And we can offer that consistency across multiple users with relative ease. And I'll see this with customers as well. Just, they want to have a development environment separated from their desktop. That way, they can do all their Git of code and pushing of code on this development environment. And if their local machine dies or something happens to it, it's not going to change it. Also, if while developing, they have to make some significant configuration issues, like creating virtual environments for your Python or installing beta versions of .NET or something, you can do that in these Cloud9 environments and not have to deal with what the implications of that to your local machine might be. So it just really gives us a machine in the cloud where we can be sure that we can standardize the way it works and work across individuals.
Awesome. And then I think this one will probably end up being yours, Christian, but anybody can jump in on these. How is Amazon ECS different than Elastic Beanstalk and Lambda? And then how do you decide which one to use?
Oh, that's interesting. Okay, well, let's see what each of those are, right? So ECS is a service that helps with containers, and then Elastic Beanstalk is a service that helps developers deploy into the cloud using traditional, well, from what I remember, traditional, AWS architectures. That's EC2, the load balancer, auto scaling groups, and then Lambda is a serverless architecture we've pioneered that allows you to just run code in the cloud without having to worry about the infrastructure underneath. So what you guys experienced today was essentially a bit of mixing of the Lambda capabilities in with containers. So Fargate is based off of Lambda, or at least the technology that powers Lambda. So a lot of the serverless architecture is through something like Fargate. Depending on what you want to do, and depending on how you guys feel as an organization or for yourselves, they all have their own strengths. So if you just want to be a dev who wants to do something traditional and have everything managed and deployed for yourself, automatically, that's definitely Beanstalk. If you are a bit savvy in terms of infrastructure and you just want to launch your code without having to worry about it, as well as worrying about the underlying infrastructure, like having to run it on EC2 instances or containers, Lambda might actually fit. So if you're using an API-based application, definitely Lambda. And then for ECS, that's more of a traditional sense in terms of containers. So if you wanted to have something that can scale in a sense and move around, definitely use ECS. But you do have that nice capability with Fargate to make it less stressful from a management of infrastructure standpoint.
Excellent. And then
Jimmy, Jay, sorry, just to add to that, we have, I think this touches on the point, we have a lot of services that you can use to run containers. I mean, you've got, just there, you're hitting on, Lambda, you can run a container there. Elastic Beanstalk, you can run a container there, ECS. But then we have like EKS, ROSA, you can technically run containers with Greengrass and with App Runner and Proton. So you often will get like, okay, so why do we have so many different ways to run these containers anyway? And it really does come down to like, there's a number of scenarios that it might be useful to have containerized compute. And AWS is reaching out to try to accommodate those different views of the world, where some are more control oriented. I want to have fine-grained control over the whole ecosystem and how I do things. So maybe I'm going to go all the way over to like a Kubernetes type, or maybe a Elastic Container Service, the one we did today, where we have a lot of control, to something where I want a lot less control. And I just want to push my code out to the system. And that would be more like that Lambda or some of these other systems we have, like an App Runner or something. But I do think there's a bit of an uphill curve on that learning curve as people come up, because they're like, okay, I want to run my container in AWS. And there's like, okay, there's like 17 ways to do this. What do I do now? And just quickly, if you do run into that, a great place to start is ECS. That is a really good place to start. And then you can kind of move, it's kind of middle of the road from complexity and control. It offers the most control with the least amount of complexity for the feature set it has. And then you can kind of go, far right with, Kubernetes to far left with something like a Lambda, and, deal with that spectrum. But it's a good place to land and start. Sorry, it's a bit of a tangent, but that was relevant.
No, great info. And then what is Graviton 2, and do I have to rewrite my applications in order for them to work on Graviton 2?
So I'll take a stab at it and see if anybody else wants to join in on there. So Graviton 2 is our ARM-based processors that AWS has developed. And this gets you away from your traditional like Intel x86 or AMD type processors into an ARM-based processor, which allows you to run your code on a system that is lower cost per compute, for that system. So you can end up running, at higher speeds CPU for less money, and that's what the ARM allows you to do. What's really interesting with ARM is you get that power, and we've seen this with a number of customers where they get that power and it just turns into a cost savings with very little change to their applications. If it's something like Java or .NET, often it's just a recompile and push, and it'll work directly on the ARM operating system. There are some caveats to that if you have a lot of libraries that you're referencing that work, third-party libraries that were compiled for x86, then that story changes a little bit. But where you have the application yourself, it actually runs pretty smoothly, and it just turns into direct cost and performance increases for less money, or cost decrease for the performance you're getting. So.
And then Jimmy, I think this one's for us. You mentioned that, in the slide that we have 11 competencies. Can you just kind of walk through what it takes to acquire a competency and why those are valuable, even if somebody is just looking for containers?
Yeah, so in order for us to achieve a competency, we have to prove that skill set. And what that looks like is we need to have several advanced use cases for each of those technologies or each of those areas. We need to provide, I think it was a minimum of 2 actual public case studies, so customers that were successful enough to sign up for, hey, let's publish this online. And 2 internal case studies. We have to actually submit the customer's AWS account numbers, right? So to validate that those services are actually used and that are running there. And then we move forward and have to present the architecture designs both to the AWS SAs and architects that run that program, as well as this also gets forwarded off to a third party who also hops in, goes through architecture design, and then really grills us on the different decisions we made, choices, technology choices, architectural decisions, really grills us across the board for their area of specialty. And then with all of the feedback from all these different sources, then it goes back to AWS for a final approval. Hey, do these guys really know what they're doing here? So, it's not a simple task. When I've gotten I have applied for a couple of these competencies myself and walked through that process, and it literally takes a couple months, 2-3 months, and many sessions, a lot of homework, a lot of meetings to get that done. But I think it definitely demonstrates that you can be confident that in each of these areas, like we are going to build it to the best practices for you.
Yeah, and I think just to add on to that, I think having the 11 now, our most recent, I forget which one our most recent one. I think the machine learning was probably the one that we got in the last month or two.
Yep.
But it does show our very vast skill set, where a lot of partners that are out there, they may have 1 or 2 competencies, but for us, especially as you're dealing with containers or going serverless or machine learning or all these various segments, it's important to have somebody that really knows the ins and outs. And so certainly with ClearScale, you can kind of trust that we've been through the ringer trying to just apply for these competencies, and certainly it's a badge of honor that we hang on. So Good question. Unfortunately, we are up against the clock at this point. But should you have any questions, please feel free to schedule a free consultation with our team. As you probably see on your screen, I had the slide out. You can schedule a call with Xander to get an introductory call. And then we can do our free containers discovery day, or move forward with any of the other offers, or just have that conversation with our team. Again, a very special thank you to Jimmy, Stephen, Greg, Christian, behind the scenes, Daniel, Tim, and so many other AWS team members for all the hours of preparation that they put in today. We'll be following up with a copy of today's presentation, as well as a link to an on-demand copy of the workshop within the next 24 hours. Again, your credentials are going to be active late into the evening, so please do continue with that optional last lab on EKS. And then we do have a variety of additional workshops rapidly approaching, including a serverless workshop at the end of July, a data lakes workshop coming soon, and then possibly even a serverless and containers workshop, which is being concepted. So please be on the lookout for all of these invitations in the coming weeks. We hope you have a great rest of your day, and we look forward to discussing containers and AWS with you very soon. So at this time, I'm going to close it out. But again, your instance is open, so please continue to work if you have the time for the rest of the day. All right. Thank you, everybody.
Thanks, everyone.
Thank you.
Thanks, everybody. Take care.
Thank you.